Welcome to the video Streamlining Machine Learning Pipelines with Open Source. In this and the next video, I want to introduce some of the libraries that we can use when we're building machine learning models. The most famous and widely used library is, of course, Scikit-Learn. Scikit-Learn contains a solid implementation of a wide range of machine learning algorithms and data transformations. Scikit-Learn has the widest implementations of off-the-shelf machine learning algorithms. It also has a wide range of implementations of data transformation classes. Scikit-Learn has a clean, uniform, and streamlined API. Therefore, it is very easy to learn and very easy to use. Most algorithms in Scikit-Learn follow the same functionality. This means that once we learn how to implement one algorithm, using a different algorithm is basically very similar. Most of the classes in Scikit-Learn correspond to one of three types. Either the class is a transformer, or the class is an estimator, or the class is a pipeline. And we're going to dig into these three types of objects in the next slides. On top of this, Scikit-Learn has a lot of documentation online with some theory, references, and examples of how to use the transformers or estimators. It is very well established in the community, so much so that new packages that appear follow Scikit-Learn functionality with the methods fit and transform or fit and predict, so that they are quickly adopted by end users. And examples of these packages are Keras, MLXtend, category encoders, feature engine, and many more. So Scikit-Learn classes can be one of three types: transformers, estimators, or pipeline. Estimators are classes characterized by having a fit method where the class will learn the parameters from a training dataset and store the parameters as its attributes, and then the predict methods where the class will take in a dataset and apply the parameters that learned from the training set to obtain the predictions. So estimators fit and then predict. And examples of these classes are the lasso regression, which we have used in the course, but also decision tree algorithms, random forests, gradient boosted machines, support vector machines, and also clustering, neural networks, etc. So an estimator class has this structure where we have a fit method that takes in a dataset and a target, or not, depending on the algorithm, and then it has some code that will learn and store the parameters, and it also has the predict method that will take in a dataset and use the parameters learned during fit to return the predictions. Transformers are classes that have the fit method and then the transform method. The fit method is very similar to the estimators. It learns parameters from a training dataset and then stores these parameters as part of the attributes. And the transform methods take in those parameters and uses it to transform the dataset. Examples of transformers are all the scalars, standard scalar, min-max scalar, etc. The feature selection algorithms, we have used it as well in the course, but also the encoders that transform categorical variables to numerical, the imputers that remove missing data, the discretizers that discretize variables, and all other variable transformations like the power transformer, the function transformer, etc. So a transformer class contains a fit method that takes in the dataset and potentially the target. It learns and stores some parameters, and with the transform method, it uses the parameters learned during fit to transform a dataset and return a transformed dataset. The pipeline is a class that allows to run transformers and estimators in a sequence. So in a pipeline, we can accommodate several transformers, and these transformers will be run one after the other. Within the pipeline class, most steps are transformers to transform the data, and the last step can be an estimator. It can be an estimator, it doesn't necessarily have to be an estimator. We can have a pipeline with only transformers, but we cannot have a pipeline with two estimators. So the condition here is that all of the transformations come from transformer classes, and the last class will be an algorithm that takes in the transform data and returns a prediction. And this is very useful to take in the raw dataset, apply in sequence all the transformations that we need, and then apply the algorithm on the transform dataset and return the prediction. To dig a little bit further in how this pipeline works, here we have an example. Let's imagine that we have a piece of text, and first we want to extract a bag of words from this text. Then we want to determine the term frequency, inverse document frequency, and then we want to perform a stochastic gradient descent classifier to predict something from this dataset. So the way we would normally do it is we set up the three classes, we initialize the classes into a variable name, just calling them from Scikit-Learn. Then we call the class and we apply the method fit and transform over the training set. The fit transform first learns the parameters and then transforms the data, and we capture the transformed data in a new variable. Then we use this transformed dataset to fit and transform the data again, utilizing now the term frequency, inverse document frequency, and we capture the transformed dataset in a new variable. And then we use this transformed dataset to train the classifier and also to obtain the predictions. So as you can see here, we need 3 lines of code to initialize the classifiers and 3 lines of code to then go ahead and obtain the predictions. If we want to transform new data, then we use the first transformer dot transform now, because the parameters are already learned from the train set, but we pass now new data, we capture this in a new variable, and then we pass this variable to the next transformer and we obtain a new dataset, and then we pass this already transformed dataset to the classifier to finally obtain the predictions. We can simplify this block of code if we used the pipeline. So we need to create an object calling the pipeline from Scikit-Learn, and then within a list, first we give the step a name. We can use the same name that we use here, and then we pass the class. We give the second step a name and we pass the class. We give the third step a name, in this case it's an estimator. And now, to obtain predictions over the training set, we just need to do pipeline dot fit, passing the train set, and then dot predict, passing again the train set, and we obtain the prediction. So this line of code is doing these 3 steps. And if now we want to score new data, we just need to do the pipeline dot predict and pass the test set. So this line of code is doing these 3 steps. So as you can see, we already saved a number of lines of code, and if instead of 3 transformations we had 20, you can see that utilizing a pipeline makes coding much easier. All of the transformers of Scikit-Learn can be accommodated within the Scikit-Learn pipeline. And other feature engineering libraries develop their transformer classes in a way that they can also be accommodated within the pipeline, and this is to facilitate the work of the end users. Examples of feature engineering open source libraries are, of course, Scikit-Learn, category encoders, that is specifically designed to encode categorical variables, Feature Engine, that has a variety of tools to preprocess features. Feature Tools is specifically orientated to transactions data and joining several different databases. And Imbalanced-Learn is specifically designed to work with imbalanced datasets. It contains techniques to undersample, oversample, or create synthetic examples in the dataset. We're going to come back to these libraries in the next video because this is extremely useful for the course. There are also open source libraries for feature selection. The main one is, of course, Scikit-Learn. Feature Engine has a lot of transformers to select features, and so does MLXtend, incorporating a battery of features for wrapper methods or greedy algorithms. And finally, there are of course multiple libraries to train machine learning models. Scikit-Learn is one of them. MLXtend has also algorithms like, for example, recommender systems. Keras is a wrapper around Theano or TensorFlow to implement neuronal networks with Scikit-Learn functionality, that is, with the fit transform. And we also have other libraries like PyEarth to implement multiple spline regression, XGBoost, Lasagne, also for neural networks, and many others. And in fact, if we check this link here, we're going to find all libraries that are available that follow Scikit-Learn functionality. So we can go ahead and have a quick look at the website, and here we can see that there are libraries to change data formats, to perform or to automate somehow the machine learning pipelines, for data visualization and interpretation, for hyperparameter optimization, and many more libraries. So feel free to have a look at this website and see if there is a package that may make your life easier as well. That is all for this video.